So hi, hello and welcome. So in this video tutorial, we're going to know about what is the functional interface in Java. So starting from Java 8, these features have been introduced in Java. So before going to discuss about functional interfaces, let us see how we have written the code before functional interfaces and how we are going to write the code after the introduction of the functional interfaces. Of course, these are topics which you are already familiar with. I hope most of you are familiar with the anonymous inner classes and all. Of course, if you don't have any idea about the so-called anonymous inner class, I will try to give a brief explanation, a short explanation regarding that anonymous inner classes also. Okay, I will try to keep this video as simple as possible, a very short video, so that you can know the complete information related to the functional interfaces and also the Lambda expressions. So here the name of the class here you're seeing is the demo class. Okay, so here what I'm going to write is I'm going to take an interface and I'm going to name it as multiply. So in this interface I'm going to define a method. So let us name the method as multiply. So the name of the method is also multiply, and let's assume that this multiply method has two arguments. Okay, so here you can clearly see that this interface is having a single method, which doesn't have any body, right? So that is what is an interface. So in interfaces you don't have the body for the methods. There will be only declarations, the so-called the signature of the function, right? So here again I'm going to take another class, name it as mathop. So I'm going to implement this multiply interface. So obviously so the editor that I'm using for this is the Eclipse editor, which is very advanced. So most of the people developers use this Eclipse if you want to develop the application in Java. So which has a lot of features which makes the developer life very simpler. Okay, so here what I have written is I have taken the name of the class as mathop, which is going to implement this so-called interface multiply. So if you are implementing that particular interface, means you need to write the body, right? So in order to do that, so if you just focus your cursor here, it is going to show you the fixes. Okay, just click on add unimplemented methods. See, it has written the complete thing, right? Public int multiply int x comma y. So this is what makes developer life very easy. Okay, so as this is the function which I'm going to the function that I have written just now is of multiply, right? So I'm just going to return x star y. Okay, so that's it. So what here I'm going to do in the demo class, which is having a main function, here I'm going to declare a mathop object. So obj1 is equal to new mathop. Okay, so after this so I'm going to print obj dot multiply, right? Wait a second, obj1 dot multiply. So here I'm giving the values as 10 and 20. Okay, so now when I run this program, I get the output of 200. Okay, so it's obvious. So what we have done is we have declared an interface which is having only one abstract method. Okay, and the next I have written a class which is going to implement this so-called interface multiply. Okay, so and I have written the code, only a single statement, it's just written x star y. So in this demo class, what I have done is I have created the object for that mathop class, and by making use of that object, by using the dot notation, I'm going to call that particular method multiply. So this is one way of taking a class and implementing that interface. Okay, and the next creating the object of the class and calling that one. So this is one way of writing. So there is another way of writing, that means you can use the anonymous inner classes, which comes in very handy, okay, which reduces your code much better. Okay, so now let us see how you can how you are going to write these so-called anonymous inner classes. Okay, so in order to do that, so I'm going to write the anonymous inner class multiply. So I'm naming this as obj2. So here we're going to write a different thing, new multiply. Okay, so I'm going to write this. Okay, so obviously it is going to show me a red squiggly line. Okay, so that means I need to write the method. That means I need to write the body for the so-called method multiply. So here, in order to show you the change, what I am doing is I'm going to take 6x star y, or let us take 2 times x star y. Okay, so in the end, just give a semicolon, okay, as this is an anonymous inner class. So now what I'm going to do is system.out.println, I'm going to take obj2 dot multiply, okay, 2 and then 3. So obviously now the value that we're going to get is 2 times 2 into 3, right? 2 into 3 6, 6 into 2 12. Okay, let us run the program. See, this is how we. So there is a difference between the previous call method call of multiply and this way of calling, right? So here don't get into a confusion. Here I have written just new multiply, which doesn't mean that we are creating the object for the interface. Okay, so here what we are doing is we're creating an anonymous inner class which doesn't have any name. Anonymous inner class means anonymous, the name itself says anonymous, that means it doesn't have any identity. Okay, that means here we are creating an object for a class which implements the so-called multiply interface. That means that's the reason why I have written the body for the so-called multiply method. Okay, so that means there's a lot of difference, right? See, here what we have done is we have written a special class for this. We have written a class called mathop which implements multiply, and this is how I have called the multiply method in the first version. This is the first version. Whereas in the second version, what I have done is I have just simply written like this. Everything I have written it here. That means I haven't taken any new class, because everything what I have to do is what I have done is everything is done using anonymous inner class. Okay, so that's how these anonymous inner classes are very, very handy to the developer. Okay, I mean, so they help you in reducing the code. Okay, so now in Java 8 you are having a feature which is called as functional interfaces, which reduce your code far better. Okay, so you can reduce code to almost a single line using these so-called functional interfaces on the Lambda expressions, the combination. Okay, so obviously for writing a functional interface means obviously you need to use the Lambda expressions. So what do you mean by Lambda expression? Is simply you can say that if you write a Lambda expression, it doesn't have any name. Okay, so we'll see how you're going to write by making use of this so-called Lambda expression. Okay, so in order to do that, I'm going to do a small change to this. I'm going to provide an annotation which is called a functional interface. Okay, so annotation means, that means what I'm telling is this is a functional interface. That means the main rule of the functional interface means it must have only one method. That means of course it might have the default methods which might contain the implementations, but it must have one abstract method. Okay, strictly. Okay, it doesn't need to have any implementations. Okay, so now according to the rule, so here I haven't written the body. I have just declared the return type, the name of the function, the parameter it takes. Okay, so this is how a functional interface looks like. Okay, so now I'm going to make use of the functional interface and Lambda expression. Okay. So this is making use of a class. Okay, so here we have done making use of anonymous inner class. Okay, so here we are going to now write this as a function interface. Okay, so multiply obj3 is equal to, so as I have said just now, in functional interface you'll be having only one abstract method. Okay, so that abstract method here, the name of the abstract method is multiply. Okay, and it takes two arguments and its return type is integer and it takes two integer values. Okay, so here what how I'm going to write this functional interface. I mean, in order to do this, you need to make use of these lambda expressions. Okay, so as I said, lambda expression doesn't have any name for that particular thing. So this is the notation that we use for the writing the parameters of a function. So here I'm having only two parameters, right? So I'm taking x comma y. Suppose, let us say, if your function is only having see here clearly, if you see this multiply, here it is just returning the 2 star x star y, whereas here it is returning x star y, right? So that means here what I'm going to do is I'm going to return 6 times x star y. Okay, so that's it. So now I'm making obj3 dot multiply, okay, 2 and 3. So now the answer will be 6 into 2 into 3, that means 12 times 3, 36. See, these are the three variations. Now I think you got a little bit what you can say idea of these functional interfaces and these lambda expressions and how these can be very, very useful in reducing the code drastically and also reduces the complexity and all everything. Okay, so this is how a lambda expression will be. Okay, so first you need to write the parentheses. In this parentheses you need to write the parameters. So here in this function, the functional interface, here the name of the functional interface is multiply. Of course I have taken the method name also, multiply. So here there are two variables which are of type integers. So here what I have done is, so I have just written the parentheses. So obviously I'm having two arguments. So these are going to, I mean, there is no need of even typing return. Okay, so obviously it is going to return. Okay, so 6 star x star y. So there is no need of writing all these things, right? Publicing, multiplying into x comma y, and then open the curly braces and then next write return. So everything is vanished in lambda expressions. It's pretty straightforward. You can reduce the code drastically. So this is the use of the lambda expression of functional interface. Obviously if you're using a functional interface, means you're using a lambda expression. Okay, so this is how you're going to make use of the lambda expression functional interfaces. Okay, suppose let us say, if at all, if you think if you need to process I mean, suppose let us say if you want to use the curly braces, okay, you can also do that. So multiply obj4 is equal to, just like x comma y. So these argument names, it's up to your wish. If you want, you can write q comma w. So it's up to you. So just write the curly brace. Okay, just write the return. So here I am returning 10 star x star y, sorry, q star w. So system.out.println, okay, obj4 dot multiply 5 and 6. Okay, so obviously 300, right? See, 300. So this is how you can write the lambda expressions. So it's purely your choice whether to go for the curly braces or whether you can just directly write in a single statement. So it's up to you. Okay, so that means if you're writing in a single statement, means you're obviously you're returning that value, because this function, the so-called function, it returns, right? It returns an integer. Okay, so this is about the functional interface and the lambda expressions. Writing lambda expressions simplify. uh, you can see, if you browse the collection API, there will be a method called for each. If you browse the list, the so-called, if you browse the array list methods or linker list or what the classes that are class and interface that are present, uh, you can see a method called like for each, which is based on the lambda expressions. Okay, where you can do the filterings and all. Of course, we will see a lot of more using these lambda expressions, but before going to fully discuss about writing these lambda expressions, it's better you know first you know about what you mean by functional interface and how you're going to use them with the lambda expressions. Okay, that's all for now. Thank you.